Good morning, everybody. Hello, good morning, Mr. Quang Chui. Are you here?
Hi, I'm here. Hi, morning.
Good morning, Quang Hui.
Hi.
Yes, I think we have some numbers of participants already joined in our seminar. So first, good morning, everybody. May I introduce this webinar this morning? Mr. Quang Hui is a developer relation manager at NVIDIA-AIEI Pacific South region focused on Vision AI. It's a great opportunity for AIEI Artificial Intelligence Engineering Institute run by CMKL Bangkok. Have a great honor to have Mr. Quang Hui to come and give a special talk on development, optimization, and application of Vision AI models for industry use case. So please welcome Mr. Quang Hui. Yep, I will give you the whole 2 mornings for you now. Okay, thank you.
Okay.
Yeah, sure. Quang Hui, I'm online, so you let me know when they're ready. I'll just do a quick introduction then before we get started.
Yeah.
Okay. Yeah, I think we can start now. Yeah, maybe you can start with the opening first.
So thank you to the team. This Atikan here, by the way. I'm just going to take a quick to do an introduction about the series of talk that we are working on. I'm just going to share my slide. Thank you very much to Professor Vanida for arranging and sharing the session. I'm just going to take a couple of minutes just to introduce what is this program about in terms of a series of talks that we are doing and how is it being structured in design. So the intent is basically to enable and encourage translational R&D by HER means higher education and research in NVIDIA term, higher education and research. So how universities and research centers can actually embark and start the journey in AI or accelerate your journey in adopting AI machine learning using many of our assets and resources, whether the hardware, GPU, or software, all our libraries, frameworks, and so forth, to enhance your research. But the research outcome should go to industry. So that is the intention of this. And given that this is a part of the work, how we have been working very closely with the government of Thailand, which is through the MESI, and also managed by AI Engineering Institute under the leadership of Professor Vanida and the rest of the universities. So what we intend to achieve is part of the program is, assuming, let's say there is 7 universities participating in this program. These 7 universities are already having AI Center of Excellence or AI Innovation Hub within the university, right? And then assuming 2 lecturers per university being trained as part of the deep learning area, where they'll become a deep learning certified ambassador to teach the content within the deep learning space where they are being trained. And the lecturers are actually given by part of the NVIDIA academic program, no cost for the university students to undertake the deep learning online courses. There is various courses that students can take. So let's say, for example, of 7 universities, we can train up to 14,000 students. So this training already started collaboration between NVIDIA and also MESI for the selected universities under the leadership of Prof. Vanida. So this is already ongoing, right? This is estimated over, assuming over 1,000 students per university over 2 years, right? And then what we are anticipating is, the last part here, is that all the research centers or COE must work with industry, work on industry problems. So while the students are being trained, the professors and lecturers are being trained in the space of how to use our platform in order to teach and also conduct research, right? The outcome that we are looking for is eventually the COE, Center of Excellence, right? AI Center of Excellence or AI Innovation Hub can do industry project. That's the intention. Okay, now, today, all the universities in Thailand participating in the program, benefiting all these benefits already, whether it's a teaching kit, whether it is a certified instructor program, or they can actually join in to get the NVIDIA hardware grant, or even applied research accelerator program under NVIDIA. All this open to the universities to do, right? So what is the aim of the series of talk? There is a 12 series of talk that we're going to do. The first talk is by Guang Hui today, but also we're going to do every month one talk. So the intent is, while universities are very good conducting the fundamental research or experimental research, they are very good at, NVIDIA, through this series of talk, we want to close the gap between the higher education research innovation activity by the university versus what exactly the industry is looking for, right? So the industry is looking for example, some kind of, not only the students who are been trained in industry ready area, skills, tools, and so forth. They're also hoping whether can they collaborate with the respective researchers in the university, work on a research problem. So today, the talk is going to cover some of the components in terms of software algorithms, which are, you can use it for your applied research. We will be sharing continuously, not only today's talk, but also other talk to cover how can you do fast AI model or deep learning model or machine learning model. How can you do accelerated modeling in terms of prototyping? And then how this can help you to do your own experimental project in the university. So the intent is to reduce the gap from what HER is very good and smart at, which is fundamental research or experimental research, but bringing in to applied research to enhance your technology so that you are very close in terms of making a proof of concept, so that it's easily can be used by industry. So this is the gap that we are trying to reduce over the series of 12 sessions, but every session dedicated in one vertical. AI today is not anymore generic. AI today is verticalized. For example, smart city or computer vision, it's one area. Healthcare, AI for healthcare is another area. AI for conversational AI is another area. So AI has gone very deep, gone into every vertical. So the intent of the series of talk is we will go by vertical. We will go in terms of sharing the algorithms and software available for every vertical made available by NVIDIA. How can you do the AI model development, enhancement, improvisation, so that you can publish papers as part of your research work in your journal and so forth. But beside that, how can you put that into a platform to make it into a close to commercializable, or POCs can be developed? Now, this is my last slide. So the way that we structure the series of 12 talks, we cover the base component. You may be doing a research for a specific AI algorithm. For example, object detection. The accuracy may be 93%. You're not happy. You want to increase it to 98%. How can you make your own algorithm much better, right? And you are publishing a paper in a journal or publishing a paper somewhere. You want to compete with your rest of the world, or you are joining a Kaggle competition, right? How can you improvise it? There is a lot of NVIDIA published research papers there you can refer. There is a reference code given by NVIDIA. You can get it. Next is, when you have the component of AI is done, next you want to put them together to make a basic POC to show the POC is working. There is a lot of libraries and tools that Guang Hui is going to cover in the space of vision computing for today. But in all the other calls, which is going to happen over 12 weeks, we will cover conversational AI. We will cover data analytics. We will cover healthcare AI and so forth. So today you will learn NVIDIA libraries and tools, right? How can you bring your AI model, whether it is EfficientNet, whether it is YOLO V4, YOLO V5, or any of the neural network that you're working on, Inception and so forth, right? Bring the model, use the NVIDIA library and tool so that you can do a quick POC, right? After that, you want to put, once your POC is stable, you want to demonstrate for your final year project, you want to demonstrate as part of your master's project or PhD project that your component of algorithm, which is innovative, inventive, published in a paper or journal, you can demonstrate in an environment to a potential industry partner or to your collaborator. So here you can use NVIDIA's open platform. So today's Guanghui is going to share many open platforms as available that you can run. So for example, you can use Jetson as one of the basic platforms that you can run. You can use other GPUs for you to put it in, right? The next is you can use many of NVIDIA SDKs will help you to drop the model. For example, in terms of Vision AI, you don't need to worry. The video is coming in from the camera into a network. From the network, it comes to the data center. Or you are deploying a robot. Robot has a Vision AI. It has a camera, the stream over 5G and goes into your backend, or even on the robot itself, you are processing. So there is SDK, for example, DeepStream, Tau, and all that Guanghui is going to present and share with you. And your model innovation is the best model in the world that you published in your journal and a paper. You just put it as part of the pipeline of the SDK. You can automatically demonstrate how this can be applied. And all the way, if you want to bring your innovation to be deployed with your partner in the factory or in manufacturing environment, or for defects detection, for example, or smart city, or retail environment, and so forth. So we have a complete flow how you can start with the component research all the way you can go to market deployment by working with NVIDIA and all our ecosystem and partners. So with that, I'll just conclude my sharing just to introduce how NVIDIA is working together with MESI and also under the leadership of Prof. Vaneda with a group of universities under IEIA program, so that we can bring to you all the NVIDIA layered technology and share with you, so that you can take it and use it as part of your center of excellence or AI hub in the university. With that, thank you very much. I'm going to pass it to Guanghui, one of the team member, to continue with the sharing.
Okay.
Thank you.
Thank you, Etikan. Yeah, so let me share my screen first. Can you all see my slide now?
Yes.
Okay, great. Yeah. So as Etikan mentioned just now, so we started the first series with the Vision AI. So later I will share about that's today's agenda. So I was starting with sharing some use cases in Vision AI and also video analytics, and then some of the research that we are doing. Not just purely on the research itself, and also how does this research translate into industry use cases. And then I will share some of the tools and also the SDKs that we have that will be helping you on your developing journey, and also not just developing, and also the deployment journey that you can have when you comes into industry. And then I will share also one of our edge compute Jetson Orin into that you can use for your development, and also use it because it's a very powerful edge compute node that you can use. And then summary and also the call to action. So let me get started with the AI revolution first. So in terms of AI revolution, you can see here we have seen a lot of vertical segments, no matter it's transportation, retail, manufacturing, airports. All these physical spaces where these spaces are getting more and more important when you want to measuring it and also managing it, especially during the pandemic condition, right? Helping to make a patient in a hospital safer, understand how does the retailer look into understand their customers and using their stores, and also the process flow inside the airport. All these things is very important, and this one is a huge market. So by having said that, how do you measuring and also manage all these vertical segment? Video as one of the important sensor here, vision, where you can see and sense the scenario and understand the scene, getting very important. So by having seen that, you need to have some analytics behind, where you need AI, where you can understand all the behavior in the region, and also the region of interest that you are looking for in each of the spaces. So that is we call it smart spaces, where you are getting all these spaces become intelligent, and then you get to monitor all these things. Yeah, I just want to show my next slide will be a short video about what are the use cases, and then what are our partners that have really done on using Vision AI to do analytics, perception, and understanding the scene. So as you can see here, basically the user, they can easily configure the dashboard, and then to identify what they want to see and what they want to know. Like, I want to do people counting, vehicle countings, and understand the behavior, how people are moving, and then the traffic condition, and then in which kind of period or time zone they may have a congestion. All this can easily be done with Vision AI and also video analytics use case. So this one is for the smart cities. Another use case I want to share is on the manufacturing side. So this is also one of the critical use case, because it actually help humans to better optimize and also make things more efficiency. As you see here, they are basically doing some defect detection. So you can see from the video, basically they are identify the wrinkles inside the cans and see whether there's any defects. So basically all these are using Vision AI and also some of the segmentation models, and then you can easily run this with your production line. Okay, so by having all these use cases, it's not very straightforward. There are a lot of challenges when you need to complete this, no matter it's from the early stage when you are training your models and create the models into a very high accurate, so that can be applied to an actual use case. So that's we call the how do you train a highly accurate AI models. And then after you have trained out the models, right, another important part is you have to deploy these things into some of the maybe some on-prem area where you need to have a very high throughput real-time analytics that has to be happen. So that's where one of the important part, we call it inferencing, where you need to achieve a high throughput in the inferencing side. And then after that, how do you deploy everything at a large scale? So how do you manage all these things? So these are some of the industry challenges when they are bringing the research part, the analytics part into the real world deployment. So we have a set of tools that can help no matter the developers or data science or application engineer to help them adapt and then fasten the whole development journey. So here's come with our NVIDIA's Metropolis platform. So this is an overview of the platform with all these toolkit and also the SDKs, and also included our hardware. So as you can see from here, the bottom layer is our EGX hardware, where it comes across with JSON devices. Later I will share more about JSON, one of our latest JSON devices called Orin. And then we also have a lot of EGX servers, and also this include all the discrete GPU that you guys are familiar with. And then on top of that, for AI application, general AI application, right? We basically have the CUDA-X library, which is used for acceleration computing, where you can convert your models from a native framework like TensorFlow into TensorRT, where you run your model in a optimized mode in our GPU, so that you get acceleration performance. And then we also have Triton Inference Server. It's a serving engine where you can serve all your models and also serve all the inferencing purposes. And then on top of that, we have a NVIDIA Metropolis platform, where it's more dedicated for Vision AI. So from the training part itself, we have pre-trained models that come across with a lot of video analytics and also image classification models, and also some of the models is built by us. It's a purpose-built model where it can do beeper detection, vehicle detection. All this we train with millions of data set for all these pre-trained models. And then we have Tau Toolkit, where you can use it for transfer learning purposes. So the Metropolis platform itself, later I will deep dive into it. So to share with you guys what are those features, and also what are those key usage of all these models. And then Tau Toolkit is also using for training purpose, using transfer learning with your custom data set, so that you do not require a very huge data set by getting a high accuracy models. And then the next one is DeepStream SDK, where you can build up your streaming pipeline, where you can get a video ingestion and then inferencing, and then doing some post-processing, even visualization of your product. So it's using it for deployment and also developing your pipeline. And then we also have Flick Command. It's a control plane where you will get to monitor and also manage all your edge compute and devices. So this is a usual developer solving industrial specific problems. They break down into different roles and responsibility. So from models training, usually will be AI developers or data scientists, where they are researching on how to get a highly accurate AI models and trying out different models, and also different fine-tuning the hyperparameters, all this, to get a high accuracy of the models, where we have all these tools to help you for the data scientists research on the model side. And then after you have a training out the models, right, that's where application developers, system architect coming in to bring the models into deployment, where used for the industry use cases, where we have a DeepStream SDK, where you can easily build up all this pipeline, and also the model that you have trained into deployment. So we are continuously doing a lot of research. So this is the page where you can browse it and see a lot of research that we have done. So basically, a lot of research that we involve also, we doing some experiment research, and also this research also bring into the application used in the industry, where you are trying to solve some issue, like how do you doing some pruning on your models, and then the state of the art or the way on pruning, so that you by doing the pruning process, you don't trade off a lot of your models accuracy, and then you can have a high throughput when you are doing this kind of process. So this is the page where you can look for a lot of research. On the research area, you can look for computer vision, where you can see all the research that we have done over there, the recent one and the past one. So I just give some example. Basically, you can have a browse through on the website, then you will see these are some of the example of the model pruning. We share how we do pruning process and all this research, and then using VisionAI on the transformer. And then this part is mainly on how do you using a transformer for vision AI, and then how do you improve the inferencing process by having some of the methodologies. So we share inside our research. You can have a look on the links. So let me get started with our Metropolis platform, where just now I share a lot about the training side, where you can use our Tau toolkit to train your models and then get a highly accurate AI models over here. So building and customizing AI models is very challenging and difficult. Imagine you have a lot of different training framework, multiple training framework, and then a lot of use cases, like you have a classification, segmentation, detection models, especially on the vision AI side, right? And then you have multiple different kind of deployment options, whether you want to deploy it into any targeted device, then you will need to convert it to specific on the devices so that it can run in optimal performance. And then not to mention also, there are huge amount of model architecture, like ResNet, even one ResNet version, there's a lot of even one ResNet, there are a lot of version, and YOLO, there are a lot of version also. So there's a huge amount of architecture you have to select from, so to train a highly accurate AI models, and also large data set that you need to train. Yeah, and also there are a lot of optimization choice, like convert it into an in-air and then doing some calibration. So here comes with introduce the Tau framework, our Tau toolkit, where we give so makes developers life easier, that you can train the models easily. Basically, we integrate a lot of good and also the popular state-of-the-art model architecture into our toolkit, where you can pick and choose from, so that you can easily training with all this framework. And then not just with that, we also have the features like augmentation, data loading, and also after that optimize the model so that it can be production ready. So you can customize all these models faster, and then deployment. So basically, we provide you a workflow from a training process that you can easily after train and then optimize it to use it for deployment. So later I will share more details about NGC, where you can use the NGC to pull a lot of our pre-trained models architecture and then use it together with Tau toolkit for training. So this is basically one of our products, the Tau toolkit. It is using a CLI command, where it's low code and the user can easily train their models with a simple command and take one of the many. So it's the Jupyter notebook that you can take and then modify all the configuration based on your needs. And then after that, you can use a command to load the data, doing augmentation, and also after that doing pruning, like the one that I mentioned. Pruning, basically you can prune the models, become a smaller memory footprint. So later I will share what are the advantage when you do the pruning on the products, and then also quantization. So basically, with a Tau toolkit, you feed in the pre-trained models, and then you use your own data, either it's a real data or synthetic data that you generate from, and then you do a transfer learning. And after that, you export the optimized models, can be used for deployment. So basically, we have a wide range of use case with hundreds of NVIDIA optimized model architecture. So like EfficientNet, YOLO v3, YOLO v4, all these models, you can pick and choose based on your needs. And then you can choose from different backbone, like so that you can fine tuning based on your needs, and then select the best models that you can train with higher accuracy. And then we also have task-based models. Basically, all these task-based models are trained by us. So we maintain, and also we keep these models with higher accuracy. Like we have models doing people detection. We call it people net, vehicle detection, traffic cam net. All this. We also have gaze detection model, gaze net. All this you can directly use it because we have trained you with very good accuracy. But you can further do your own transfer learning with your own use cases to make it better inside your use cases. And then highly accurate. So all these models, as I mentioned, the people net that we maintain by ourselves, where we continuously improve it to make it better accuracy by feeding all this new data set. And then we also have quantized the model where you get a smaller footprint, and also you get a very high throughput when you use it for deployment. There's an inferencing throughput. So these are some of the examples of our pre-trained models that I have highlighted. So there are vision AI models, and also we also included some of the conversational AI models you can see here. So basically, we tested out with all our devices, and then we do some fine tuning and optimization so that you get a very high throughput when you are using it for deployment. So this is some of our NVIDIA optimized models compared to the state-of-the-art accuracy. Basically, all the models that the pre-trained models that we bring into Tau Toolkit is state-of-the-art. So we have keeping all this state-of-the-art accuracy at least on par, or some you will see we have slightly better in the accuracy. So basically, you can use it for better transfer learning, and then get your models based on your use cases, getting a better accuracy. So we have a lot. We basically also have a lot of technical blocks, and also the developer blocks guiding you guys on how to achieve all these state-of-the-art throughputs, and also some of the best practices, and also the tips when you are using all these models with our Tau Toolkit. Okay, so this is the one that I mentioned just now, the task-based model that we have. Basically, we optimize with high throughput and then train with high accuracy, and then add that with Tau Toolkit, where you can do your own transfer learning based on your current use case. So the next one, the question will be how can I get all these models from? So how can I easily get the models? So we have this NGC catalog. Basically, is our repository. So we containerize all these pre-trained models, and then not only the pre-trained model itself, together with a Tau Toolkit, and also some of our other SDK, where you do not need to install everything from the bare metal and then from the scratch, right? So basically, when you pull a container, you can directly use all these toolkit. So I know it's a hassle for developers when you need to make sure all the libraries dependency are correctly installed, so that you will get any error on that. So there's a lot of environment variable that you have to taking care on. That's why we have this repository where you can register it. It's very easy. You just need to register, and then you sign in. Then basically you will get a URI, and then you just use the URI and pull the container. After that, you access the container, then you can easily use it for the environment, for your development. So this is the website. How is it looks like? The NGC catalog. Basically, you can search a lot of the model that I shared just now. Some of the pre-trained models like PeopleNet, or you want to use our model architecture like YOLO v3, YOLO v4 with the Tau Toolkit. All this can be found over here. and then you just select what are the containers that you are looking for. Basically, we have all the description inside each of the catalog. Then after you select, then you just pull the container, then you can start your development. And then some of the pre-trained models that speed up of the AI development that I think I have highlighted most of it. Basically, all this model architecture that we provided in the How Toolkit, we do a lot of pre-training. So basically, you just need a minimum data set, then you can train with a high accuracy with all these pre-trained models. And also we integrate with Google Cloud that you can easily run the instances with all these with one click, and then you can run all this inside the Jupyter Notebook, run on the Google instances. Yeah, and then these are some of the demo about our pre-trained models, where like the one that I mentioned, the dashcam traffic net, basically for vehicle detection and also identify the vehicle type for this. So feel free to download it and play around with all these pre-trained models, and then using the Tau toolkit, you can fine-tuning it for better accuracy. And then these are some of the key features that I want to highlight regarding the Tau toolkit. Basically, by having your own data set is not enough for training a highly generalized and then good models. So what usually the data scientists will do is mainly on the data augmentation. So we have a lot of augmentation methodology that you can configure. Basically, is you just need to configure it, and then you can set up like blur, special, and also different colorization, so that you get to spawn more data set for your training purposes. And then other thing that you can do is you can adding in some features so that you can use it for like different camera types. One of the example is you use a PeopleNet models and then fit in with a thermal IR data set. So it's for mainly for night vision, where you can adapt it and then train the model so that it becomes a model that can detect during the thermal IR cameras for night vision. And then another part what you can do is also adding new classes. So by having the PeopleNet, and then you adding new classes like to detect helmet or safety vest, all these things you can do for safety security kind of use cases. And then you fit in all this model and then transfer learning with your own data set to get a certain level of accuracy with that. And then the pruning process. So this is one of the very good methodology or technique where you can reduce your model size by pruning off some of the unused connection. And then basically, as you can see here, the model size being reduced by 8 times. Okay, so by reducing the model size, you basically get a very high throughput. Yep. Can anyone help to mute from their side? I think there's some background echo from my side. Yep.
เพื่อนช่วยปิดไมค์หน่อยครับ
Okay. Is it okay now?
Okay.
Is my voice okay?
Yes.
Okay, great. Yeah, because just now I heard some echo. I'm not sure is it from my side. Yeah, okay, great. Yeah, so basically by doing the pruning process, you reduce the memory footprint, the model size reduction, and then you get the high throughput. Where the throughput improvement when you deploy at the site where you can run higher FPS So this is one of the technique and also the methodology of using this pruning method. So it's very easy when you're using the Tau toolkit, where you just need to configure the file and then run the CLI command with pruning. Then you can set different type of threshold based on your needs, and then you can start the pruning process. And then also quantization is one of the important part when you need to after you train the models, then you need to optimize it for a deployment scenario where post-training quantization is a common one. And then we also introduce the quantization aware training. So what is about this quantization aware training is when you're doing a quantization process, it won't lose about a large accuracy. So by doing just direct quantization, sometimes you will lose a lot of accuracy, because from a FP32 into INET, basically you shorten all the integer that the range they have. So sometimes it lost some accuracy. By doing the quantization aware training that you can easily configure with a Tau toolkit, you maintain the accuracy, like, and the accuracy loss is less than 1%. But you can see from the right hand side that you get a huge improvement in the throughput, about 2x compared to a FP16 kind of performance. Yeah. And then also the Tau toolkit also support automatic mixed precision, where you can accelerate the AI training process and also reduce the memory bandwidth that you are using. And then you can see from here, basically it's one line of the command that you can execute this process, similar to all the one that I've shared, right? Pruning, and also the quantization aware training. All of this is a single line of code, but you have to have your configuration file ready, and then you can easily train it. Okay, so after you have all the training ready, the models, right? The models ready, train ready and optimized with a high accuracy, and also quantize it into INET. Here's come with your deployment, where I show an role and responsibility earlier about the industry use case, where data scientists or AI developer train out the models. Then they give the models to the application engineers or system architect. Then what they take the model from, and then they will use it for deployment. So this stream SDK basically is used for building up your own streaming pipeline. So this is some of the common pipeline that usually involve, no matter it's image processing or using it for video analytics. So basically, you are using a sensors like the camera. You are pulling the RTSP stream, capturing it, and then after that you do a decoding, the video decoding. Then after that you do some pre-processing and also the batching before you feed into the AI inference. So this is where your models sit in the AI inferencing. But for the whole deployment process, like here mentioned in the title, it's not just about AI inferencing. There are a lot of things, other things that you have to consider in an application level. So AI inferencing is one of the piece. And then after you have the inferencing on based on your model, let's say you are doing a object detection. After you detect the object, what you want to do with the detection, usually they come together with tracking. So I want to track this object to understand some of the behavior on the scene. Then after that, you have some business rule and also the further analytics on all the metadata that you're getting from AI inferencing. And then also the last part, the visualization. So it's not just the AI inferencing, you have the models ready and can direct use it for deployment. You still need to create the streaming pipeline for that. So here's come with our District SDK, where it's our NVIDIA platform, where you can have all these pipeline being created easily with this way. So basically, we create all these as a plugins, like capturing and also decoding plugins. So all these plugins that we have provided is a hardware accelerated plugin where you just need to line it up and also forming based on your needs. And also it's like playing a Lego. So which plugin come first and then which plugin connected with another plugin. So you line it up with plugins of based on your use cases. And then all this plugin basically we doing a lot of hardware solution. So you do not need to care about whether this plugin is running on our MV decoder API or the GPU cores. All these things will be handled automatically by the District SDK. So you just need to focus on your application level to form out the streaming pipeline, the overall pipeline. So, and also with this plugin, we also doing a lot of memory efficiency so that we make sure there's zero memory copying. So this is a usual pipeline and also the plugins that I've shared. So basically, the first step, you have to capture the stream from the GPU and move it to the from the CPU side and move it to the GPU memory. So basically, by moving this, you might have occur some latency because of you are moving into memory, right? But after you are getting into the GPU memory, all this memory are sharing each other and being reused. So by running decoding, batching, inferencing, there were no memory copying process. So in terms of throughput and also streamline the process, right, you are getting a very high throughput by doing so. So we help you to manage all these memory execution. You just need to focus on how do you build your pipeline in terms of utilizing all these plugins. So this is our latest District SDK 6.0. So we have a lot of options that you can use to build up these plugins. One of the latest version that we have, basically we have this graph composer where it's a UI based, where you can drag and drop all these plugins and then line up and then forming up your streamline your streaming pipeline. So we also have a C++ and also Python binding code where you can use to build out your own pipeline. So we're giving out 3 different options. Which one is easier for you to build out the pipeline? Then you can use it from there. And then we also have a lot of samples, different models within it where you can use it, like action recognition net, where you can detect action. So we have a sample over there that you can directly testing it and see how does it perform all these things. And then we also have state-of-the-art trackers where you can use it as these plugins for tracking purposes. And then also gRPC for the communication protocol, where whether you want to send it to the backend or using it together with Triton Inference Server, that can be done with gRPC. And then the RiverMax support, basically this one require our Mellanox NIC card. Basically all the incoming packet from the streams, it goes direct to the GPU memory. Instead of going to CPU, you direct go to the GPU, you fasten the whole process on optimize the compressed data packet. And then we're also adding in a lot of IoT connectivity, like Kafka, MQTT, or the Greengrass from AWS. This basically you can use it for transmission of data into a backend or cloud. Yeah, so basically we are helping you to solve all the design complexity, optimize the total cost of ownership with the performance that you are getting with different SDK, and also is a single code base where you can run on multiple targets. No matter you are running this stream into a JSON device or a discrete GPU or running it on cloud, basically is shared across all these target devices. So this is the one that I mentioned. So we provided different options for developers, whether you are using a Python or you are using a C++, or you prefer to use a Graph Composer that I've shared. You can use it for your development. Then after that, it will be ready for your streaming pipeline and ready for deployment. And then everything can be containerized. So another example that I want to share is about the trackers. You can observe from here where how does our NVDCF, our state-of-the-art trackers, using the visual similarity to track the object, and also even with occlusion happen, you're able to track back the same object. Okay, so this is the video. You will see that there's a lot of occlusion happen, which block the white vehicle over there. And then this is behind the scene where how we do the correlation, and then based on the response map, and then you are able to track back the object to identify the same object, although there are some noise and blocking or distortion. Yeah, this is the same one that I highlighted. So basically, with different SDK, you also can achieve a very high throughput, because you are basically using a GPU for decoding process where you feed in all the video streams, and then these are some of the benchmark where we have done on our GPU, where you get a high throughput performance on the decoding process. And then this string SDK and overview, basically I have shared all the things, single one code base where you can have multiple target, no matter it's on-prem server, edge device, or cloud. And then DeepStream also work with different library that we have, like CUDA, TensorRT, and also Triton, and also some of them multimedia, mainly on the decoding side that we use, decoding and coding plugins that you can utilize. Everything is integrated with our API, where you can accelerating the whole video analytics process. And then on top of that, that's where we have all these pre-trained models that I've shared that you can use it on different SDK, and also this support on the AI models update. And also Helm chart, basically you can containerize the whole deep stream and then create your Helm chart for that, for easy deployment in the future for any devices, and also IoT messaging. And then on top of that, all the development environment that you can utilize, 3 options that you can use. The next one, so basically I have shared about what you can utilize on the training process with Tau and pre-trained models, right? Then I share about the different SDK that you can use for your inferencing, for your video analytics pipeline. Then we also have this Triton inference server. This is more on a general purpose on serving all your AI models, and also as a serving engine on the inferencing side. So basically, this Triton inference server give you the flexibility, so you can support a lot of major framework and also the backend. So you get the flexibility to run the TensorFlow, PyTorch, on its runtime. Even also you can run TensorRT directly with a Triton inference server, so that and also this one, when you run in our Triton inference server, basically you get an optimal performance if we're doing some model analyzing where you can use it to identify how was the models perform, all this stuff. And then also you can get to configure the inferencing running on GPU, CPU, and also the mixed load so that you maximize the hardware utilization. There are also a lot of different type of queries that you can run on the Triton inference server, like real-time batching, dynamic batching, ensemble of the models. So you can run multiple models in the concurrent mode and also get a faster throughput. And then this is Kubernetes integration. And then you can build up your own CI/CD process where you can continuously updating the models and continuously deployment to your targeted device. And then Triton Inference Server also is an open source where you can find it available on GitHub, where you can do your own customization. So yeah. Okay. So just now I have shared many of the software stack and also the SDK and also the toolkit that you all can leverage on. Let me come into a little bit on the hardware side. We recently released a new JSON family. It's called Orin. And then this Orin is a very powerful device. And this is because what we have observed in the market where there are more and more demand on the massive compute and the edge processing. So traditionally or previously, we have a lot of vision AI using it for sensing, perception, like the earlier one that I mentioned. So you do object detection, but by having all this data that coming in, we are getting a lot of perception data where you can understand the scene, whether it's a people, whether it's a vehicle, whether it's a traffic light. All this we already done a lot of sensing and perception. That comes into the next step where people are more concerning about what is the reason behind the insights, where you come into the insight. After you have a perception, then you want to know how people behave. Like the earlier one, I share a use case on the smart city. You want to know what periods of what time there's a congestion happen usually. So based on the data that you have collected and also the time frame, you want to know the reason behind it and also the insights. And after you are getting the insight, you want to acting. So sometimes all this can be happen in a real-time manner where you need a lot of compute and also a lot of analytics at the edge because you want to have this in a very fast responsive. And then also definitely there are more models and also the use cases bring into the edge compute where you can run a lot of things. So that's why we introduce about the new family. It's called JSON Orin. So we have a series of Orin coming out this year. So we have Orin NX, and then we have AGX, which is the higher end. So let me share about how does it compare to the previous generation. So the Orin basically is running on the NPL architecture. And then this is some of the performance benchmark that we had done compared with our previous JSON Xavier AGX Xavier. So as you can see from here, it's around 8 times on the in-app tops performance, and then you are getting a 4x FP32 performance on the CUDA side. and then also the DLI within the JSON family that you are getting a performance like 9x, and then also the enhancement of the CPU inside the JSON is around 2x on the CPU performance, and then as well as the memory. So basically, we also have an improvement on the DRAM memory within the JSON module itself. So this is some of the benchmark that we compare with our pre-trained models that I shared earlier. So the table here basically is all the frame per second FPS. So by having the hardware itself is like 3x to 4x of a performance, and then we continuously optimize with our software stack. Like we have a Jetpack inside the JSON devices where we continuously improve that around another 1.5x. So we are getting like a 5x 5x of improvement in the models. So these are some of the series that we have on the Orin family. So you can see from the right hand side we have a series from 7 tops in-act tops to 275 tops on the performance where you can get based on your own needs and also the use cases, the deployment. So basically you get a huge improvement performance, but you are getting a similar price compared to the previous generation. Yeah, so the development kit is already available today. So you can start your development today with Orin development kit, where one of the features that inside the Orin have is you can run an emulation mode. So let's say the emulation mode can run on all the 4 AGX Orin that I have shared just now, 64 gig, 32 gig, the 8 gig NX, and also the 16 gig NX. So by having this, you can know what is your benchmark and also the performance you are getting on the Orin NX, all this, and also the AGF performance, so that you will know which one will be suitable for using it for deployment. So this is my summary of today. So basically, I have shared about the end-to-end AI development pipeline, where you can use the NGC catalog for pulling out all the pre-trained models, and also even some of the toolkit and also the development environment that you can pull it from there, and then to start your development journey. Then after that, you get your own data set, and then further transfer learning and train it so that you get your optimized models, highly accurate AI models, and then after that you fit into the deployment framework like DeepStream SDK is one of it. So Riva is another one that using for conversational AI. So I think that's come in after the other series, and then Triton as a generous serving AI inferencing framework that you can utilize. And then we also have other SDK like video storage toolkit is mainly for managing the storage and also doing some camera management. Yeah, so and the last part where you can use Flick command as a control plane, where you can do one-click deployment and also manage all your edge node with the Flick command for easy deployment and also the scale out. So this is the end-to-end development pipeline, and with all the tools that you can utilize during your development and also your deployment journey. So these are some of the resources that you can see from here. Basically all the links and also some of the useful guidance and also the development. We have a developer guide forum where it is resources where you can look at in the community, no matter it's the new project that they are having, or the new development that they have, or the issue that you might have, you can raise out the ticket over there and post it in the forum that we have a lot of engineers to help you to solve your obstacle. Yep, this one is my last slide. So the call to action, try out all the SDKs and toolkits today with the resources provided. So basically all the information that I said is publicly available. You just need to Google and then you can find all the information. And then we have free DIY courses where you can register it and then you get to access and then to try out some of the tools that I've highlighted, like How Toolkit, and also try the inference server. And then there are more DIY self-paced courses that you can try out. So basically you can find it over this link. So basically you can start learning from today with all these exercise. And then subscribe our NVIDIA developers newsletter and also the technical blogs so that you get updated with some of the no matter it's an event, webinar that we will have, all this you will get the latest information, and also the technical blogs, as in we always share some things like tips and also the best practices on using some of the toolkit, and also training some of the models or deployment where you can run containerize or the Kubernetes, all this stuff to getting a scalable solution. All this we are sharing in the technical blogs. To subscribe it, and then this one is the last part is to call out for all the new startup. So if you have a startup coming up, do join our insertion partner programs, where we provided some of the benefit over there. Everything is shared inside the website that you can see over there. Okay. Okay, so yeah, that's all from my side. Any question that you all might have want to ask? So I'm open up to answer your question. Yeah, are you all? Okay. So while waiting for any question that you guys might have coming up, right? So let me share something as well. So that there are the links that I have shared just now. Basically, can you all see my web page right now? I'm
Yes.
showing.
Yes.
Okay. So this is the Inception Partner Program that I've highlighted. There are some program benefit that you guys can get by joining this program. So you guys can take a look on that. And then this is the research one that I have mentioned about. So basically, you just search for NVIDIA research, and then the first one, and then you can look for what is your interest area. So basically today I highlighted some of the computer vision one, basically the vision AI part, where you can see some of the research that we had done over here. And then these are some of the sample that I've shared. And then this is the technical blog that I've shared earlier. So do join up some of the subscribe, and also join our developers newsletter so that you can get all this information over there. Yeah, and also one last part is our NVIDIA DIY course where you can learn something over here. So there are a lot of free courses over here that you can learn online. The self-paced one where you can learn all these things the one that I share, basically also inside here, basically you can learn about Tau 2K and also the Triton inference server. All this you can see from here. And then the last part I think I forgot to mention is the NGC catalog, where it's very useful for your development because you do not need to install everything from scratch. Basically, you can just download it, pull out the whole container from here, and then you can start your development journey. So like some of the SDK, the different SDK basically is here. You do not need to install from scratch where you need to install the dependency library or this stuff. You just pull the container. And then some of the pre-trained models that I highlighted, like if you are looking for classification models, some of the different framework, and then you can use it directly together with the Tau toolkit. So basically we provide the guidance over here. You just need to register and then to sign it on. Okay. Yeah, so basically all this information are available publicly. You can easily search it. Okay. Yeah, that's all from my side. Yeah, feel free to let me know if you guys have any question. I'm open to get any question that you guys have.
About your presentation today's slide, it is any possibility that you can share to the others?
Yeah, sure. I will share this to so who should I share with? Can I share to Pangkyo? Maybe ask Pangkyo to share with you all.
Yes, please. Yes, please.
Yeah,
And,
sure.
And some of our participants also asked for, the video clip that recording of your presentation today. Please visit to aiei.tech. Later we will, upload the talk. Yeah, today.
Okay.
Thank you.
Okay. Yeah, do share with me also if you guys have any feedback on the talks, and then what are the other things that you guys wish to see in the future, all these things, and also what is good for you all. You can let us know as well.
Yeah, thank you so much, Kang Hui, for your fruitful talk this morning. And I also would like to pull up some polls for us here, please. All participants, please feedback what we have done. And as earlier, Dr. Itiken said that these kind of events we're gonna hold every month, the last week of Friday. So today is a great honor that Dr. Kang Hui spare his free time to come and share the technical knowledge of how we can do the vision AI, especially in industrial case. And it's very interesting that you have shown not just the libraries. We have to later on have a hands-on workshop and see what's going on. Yeah. So please, yeah. Now I launch the poll here with everybody here online. Give a feedbacks and just a few 3 questions, please. And earlier we announced that every participant who involved in this kind of seminar sponsored by NVIDIA, the IEI Artificial Intelligence Engineering Institute run by CMKL, will later on will send you email how you can get the certificate of participants. All these participant certificate is very essential if later on in the near future you wish to obtain the degree by CMKL. You can ask for competency assessment later on. Yeah, and this is kind of great activities that NVIDIA is very kind to us to the Thailand AI University Consortium. Yeah. normally we have to spend lots of money in order to access all these fruitful workshop and also up to trend and state of the art technology.
Yeah, thank you for hosting this with us as well. So yeah, we are happy and also to share all this knowledge that we have to all the audience, so that you guys, I hope you all get fruitful information from me, so that can help you on your development journey for sure. Okay, thank you everyone.
Thank you again. So this morning session is already finished. Thank you again, and we do hope we're gonna see you again sometime next month. Yeah.
Okay, thank you everyone. Okay,
Thank you. Bye
have a
bye.
good day. Have a good
You
day.
too.
Bye.
Bye bye.
Thank you. Bye bye.
Thank you.
Wait, I thought the meeting is supposed to last till 12.
Actually, because the speaker has already finished his talk, so yeah.
Oh, okay.
Yeah, because I reserved last 15 minutes for a Q&A session.
Yeah.
Yeah, okay.
Mhm.
Thank you. Thanks everyone.
Okay.